Hey, so yeah, as introduced, my name is Wojtek. I came to you from Poland, and I will be talking today a little bit about libraries and libraries, and probably more libraries. But before we go into the libraries, we all love frameworks, right? No, seriously, who loves frameworks? Who like frameworks? Oh, okay, this much more than I expected, to be honest. Personally, I hate frameworks, but for some reason they have a very strong user bases. So if you think about stuff like Play or Spark or Ruby on Rails or Django, all of that have a huge user bases. And there must be a reason for it. My theory is that that's because when you go with a framework, you have all the batteries included. You just go to the site, you follow the docs, and you get most of the tools you need to solve your problem. But at the same time, the frameworks are not so nice because joining them with another different libraries from outside of the framework is hard. And there's a lot of magic typically hidden below the framework layer, so it's hard to understand. And so, at least for me personally, I don't use them. But what's the alternative? The alternative are libraries. And this is great. Like, you have these small pieces that you can join together, and that every single library do a single thing and do it well, right? This is how the libraries are sold. But it's not for free. Like, when you go with the libraries, you have to compose a stack out of them. So you have to pick the right libraries to solve your problem. And that takes quite a lot of effort. And the goal of this talk is to show you the set of libraries that works pretty well, and also show you how to make libraries work well together in general. So I call this ecosystem. And we'll create an application. And when you create an example application, you either go with nodes or to-dos. And we're going to go with nodes. So there is a node, it has a title, and it has a text. We can save the node, so you take the node, put it somewhere, and keep it there. And you can retrieve the nodes back, so you take everything you saved before. Easy, right? I hope so. So this API we need to expose somehow to the user, and we will use REST, because everyone knows REST. Maybe we should be using GraphQL, as John advised. But let's stick to the REST for now. So the creation becomes a POST request, the retrieval becomes a GET request, and the node itself is a JSON document. Nothing very interesting here. But when we start working on that, we have to make some hard choices, and the first one will be HTTP server. So we want to implement the mentioned REST, and we need to choose. And there is a couple of options here, so the 6 are probably the most popular ones. And I'm going to make this choice for you and tell you about HTTP4S. So the HTTP as a protocol is functional by its nature. You just take the request, produce the response. But at the same time, it's also effectful. So you would typically go to the database or to the file system or to another service, make an HTTP call, and all various stuff. So this is why we have this F wrapper. And this is probably a good place to say that during this talk, whenever you see something you don't understand, just ignore it. So if you're not a functional programmer and you don't know what is the F here and why do we need it, whatever, just ignore it, it's not important. OK, and then continuing, we have also option here because you can take the request and not handle it. So the function is also partial. Like you may want to ignore most of the requests and serve only certain paths. And the same is expressed in HTTP/S. So there is this HTTP routes. It takes the effect type F, and it's just a function from request to response. Only that it's a little bit more complicated. So if you look under the hood, inline everything, you end up with this Claisley option T stuff, which may look a little bit intimidating, but it's just a wrappers around what we had before. So it's semantically, it's the same thing. So our API, we need saving nodes and getting nodes, and this will be two HTTP routes. And this is the very basic implementation of it. We pattern match on the request with this syntax of HTTP routes off. And in case of the post request, we produce hello. In case of get request, we produce world. And that's it. How to use this thing? You just take these two routes, you join them together, you bind to a specific port interface, some boilerplate, and you have server up and running. And what is important here is that the composition here with this magical operator, Starship, or whatever you want to call it, it's not some random thing coming out of the HTTP/S API, but it's a part of CAT's syntax for semigroup K. And it doesn't matter what semigroup K is. The important part here is that it's not a random method, and you will learn why later on. But we don't have the JSON. I promised you that node will be expressed as JSON file. And so we have a second hard choice. We need a library for JSON serialization. And here, once again, we have a couple of options. And in the Scala community, there was a time when it was told that every senior Scala developer has to create a JSON library. And so this 8 survived, kind of. Yeah, and you can see this magical number at the bottom. So right now we have 6 libraries for HTTP, 8 libraries for JSON, and we have only 48 possible composition of those. And I can promise you this number is not gonna be smaller. And let's look at Circe. And if I don't have images, it will be a little bit bad, but not that bad. OK, and so we have Circe. And the main thing about Circe is that this library is totally pure. So whenever you do an operation that can fail, like parsing can fail, obviously, you don't get any exceptions. You just get an either. And when you decode stuff from the JSON, like you want to case class from your JSON, this operation can also fail, and you also get an either. And you have to handle that. Or you can just ignore it, as I did here. But at least Circe do its best to keep you safe. And yeah, it also doesn't use any kind of reflection. But at the same time, using Circe is kind of easy. So if you have nothing against this style when you derive the codecs from the case classes, it's enough to put an annotation on the case class, and you can already decode it from the JSONs. But this is the first place where we need to integrate stuff. So we had the HTTP/S before, now we have a Circe, but we kind of need to make one understand the other. And it seems that it's pretty simple. You just put 2 magic imports at the top, and from that point on, you can decode your case class from the request, you can encode your case class into the request, everything works. And it's pretty seamless. But we haven't kept our nodes anywhere, right? We don't have any kind of storage. And this brings us to the third hard choice, and it's database persistence. And here, once again, we have a couple of options. and almost 300 possible stacks. And this time, I will show you not one, but two libraries. And I will show you Doobie and Quill. So this is what we need from our persistence layer. We need a way to initialize database, so apply some schema evolutions probably. We want to get the, save the node in the database and retrieve the nodes from the database. And with Doobie, it's simple. You just write your SQL, you put it in the SQL interpolator, and this is your query. Doobie will automatically take care of encoding the parameters. So whenever you put some variable, as I did here with node title, for example, Doobie will create a prepared statement. So it's not just plain stupid string concatenation. It's a prepared statement. Everything will be encoded. You're safe from SQL injection. And then as long as you have a transactor, you can get your results to any F-type. So it's so-called effect polymorphic, just as HTTP4S was. But SQL is great. I really love SQL. I build systems on top of that. But for the typical crude applications, create, read, update, delete, it's a pain. It's a huge pain, in my opinion, just a pure boilerplate factory. And I don't want to be writing those SQLs. And this is where Quill comes. So Quill allows us to generate SQLs in compilation time. And how does it work? You start with a context. There are various different contexts. And you define your case class. And my formatting is a little bit weird. And then you just put you use this magical quote method, and it's a macro. Whatever you put inside this call will be analyzed by the macro and transformed into SQL query. So what is important here is to understand that this code inside the quote will never be executed. This code is erased completely during compilation, but it's transformed to a SQL prepared statement or something isomorphic to that. Then you just take the query and run it, and you get your results back. So Quill works like that. But previously I talked about Doobie, now I'm talking about Quill, and they do the same thing. So it turns out that Doobie has a support for Quill. So you can still use Doobie for executing the queries, and Quill for constructing them, which joins the best from these two worlds. So instead of the Quill native context, you just take the context from Doobie, Doobie Quill module, and just use them both together. And this is yet another integration. And this is also really, really cool. And if it happens that you use Doobie with Postgres, then maybe you are keeping JSONs in Postgres because it has a quite nice support for it. Then you may want to also use CRC for those JSONs. And because you already have that, we use that for the front-end communication. And then you can use the Doobie CRC integration, and it just works. So you can get the CRC objects directly from the database. But I cheated a little. I told you that we need a transactor, but I haven't told you how to create that. And it might be quite easy. So you can just pass the URL there, the credentials or whatever. But in a real-world application, it's not how it's done, right? We need a configuration library. So you want to pass it from the external world, probably, not to hard code passwords in your code. And this is yet another choice. And I have 5 here, but I think yesterday it was announced that there is ZeoConfig now. So I wanted to add it, but then I would have to fix all my calculations, and I'm a very lazy person. But you can think of there are 6 here. So I will show you Cyrus, which is a configuration library. And I will give you a quick 101. So how to use that? First, you need to define the strategy for extracting your configuration parameters. So here we say that you should take the environment variable, Magic API port. If it's not there, go for the property, Magic API port, treat it as an int, and if the properties were not defined, then just default to 8080. This is pretty simple. Once you defined those strategies for all the values you need, you can join them together. So you have the API config, which is address and the port. So you take the config value for address, config value for port, and you join them with this parmap_n method. And what is important here is that it's not some random API coming up with Cyrus, but it's leveraging the cat syntax for parallel type class. It doesn't matter, you don't need to know what this type class is, because the documentation of Cyrus will tell you how to use that and so on. The important part is that it's not a random method specific to Cyrus. And once you have defined all your configurations, you just call a load method, pass the effect type, so it's cats effect IO or Monix task or ZO or whatever, and it just loads it to your application. But now let's make a step back. You remember this little method. Can you see anything particularly wrong with it? Like from the perspective of the production application? Oh, of course, it doesn't have any filtering, but let's skip that for now. The problem is that we keep all the data in memory with such signatures. Because we go to the database, we take everything from there, and for this period, we have to keep it in memory. And if you have like gazillion of nodes, then it's not gonna fit. In no way. So we need to stream those. We need to stream those from the database, and we need to stream those to the user. And this is yet another hard choice. We need a streaming library. And we still have a couple of options, and ZO is obviously here. And we only have like almost 6,000 possible stacks, different sets of libraries. And what's up?
Battery.
Okay.
Просим прощения за задержку. Все.
Okay, now we can continue. So let's go with FS2. So the FS2, if you have ever seen it, it may look a little bit intimidating, but I really advise you to give it a shot. So you can think of it just as a regular collection, like you know, but with the capability to execute side effects when requested. So in this example, we have the URLs, the list of URLs or sequence or whatever. Then for each of those, we go to the internet and fetch stuff. We get the body, we parse the body as UTF text, because it's bytes in the very raw form. And we split it by the space, we fold it to one. So we basically count words in each of the, in such bodies. And what is important here, that when we define the stream, nothing got executed. So there was no call to the internet made. Then when we do this next statement, so we compile it to our effect type, it's still no call is made to the internet. It's still deferred. Only once we run our effect type, it actually evaluates what we asked it to do. So we can transform and modify the stream as a pure value, and then at the end of the world, execute it, which is nice in practice. So, and FS2 has also this additional feature that the stream, you can register hooks in the stream. So you can say that I have a stream of connection pools. And in fact, this will be a single element stream, which might look a little bit confusing, but you do that to register a hook that will close the connection pool on the stream termination. So when the stream processing is completed, it will close the connection pool, allowing you to save resource deallocation. And this is basically equivalent to Katz effect resource, if you're familiar with that. So it's just a stuff that allows you to register a shutdown operation. So how to use that? First, we need to do this on the database level. And this is simple, because Doobie is built on top of FS2. So when you need the stream, you just replace run with a stream, and that's all you need to do. Our old f of node, list of node, became the stream f of node, and that's it. And then we need to pass it to the user. Like, take one element from the database, send it to the user, and forget about it, then take another one. And how to do that? It turns out that HTTP4S is also built on top of FS2. So you don't need to do anything. You just take the stream from the database directly, pass it to the response, and FS2 will take care of streaming that. So nothing is kept in the memory for a long time. So it's chunked, but you can control that if you wish. So it's awesome. And it's very, very simple, because those two libraries share this common part. So right now, we have the server prepared. We implemented the API, very basic one, but it's kind of complete. Now, we need to write a client. And because writing a web client would take me at least 2 more slots into the presentations, we'll create a console client. And when you do the console client, you need something that will parse the arguments. And here I was wondering for quite a long time if I should include those libraries in the stack calculation, because it's not something you typically use. But it doesn't really matter. So there are 4 options in Scala to parse the console arguments. And I will talk about decline. So this is what we want to achieve. We execute a program, we pass a command there, some additional arguments, and our stuff gets executed. And how to use decline for that? The optional first step is to define your comments. So you don't have to do this, but it's useful. So you say that you have a get nodes operation. It must contain an URL and the port. And you have an add node, which contains the URL, port, and a node to be added. Simple. Then how to use that? We need to define a strategy to extract those stuff. And if it reminds you the Cyrus, it's a good thing, because it's very, very similar. We say that we want to take the option from the console arguments, URL option. So it will be 2 dashes URL and the argument. The argument should be of type string, so no conversion is needed. Otherwise, if it's not present, try for the environment variable. And if it's also not there, fall back to localhost. Then you need to define those for everything, so URL, port, title, text, and then you join these things together. And when you join them, you use this map-n function. And what is important here, that it's not some random function from the decline API. It comes from Katz syntax for semigrupple type class. And you don't need to know what semigrupple is, but you know that it's not specific to decline in any way. It's more generic than that. So you join everything together, and then you just run it. So you use it in the main. There are some helpers here, but they don't really matter. You just basically take your command, you pass the command line arguments there, and you get the result of parsing. Decline will also give you this help page for the user. So this is the main one, but if you go to the command, like magic get nodes ---- help, then it will have another page for the subcommand. Yeah. So we have the interface for our client application. And now let's consume the API. And what do we need to consume the API? We need an HTTP client. So how does it work? We have to choose from one of those 5 libraries. And as far as I know, Zio doesn't have an HTTP client yet. So it's only 5 of those. And we have only 100,000 different stacks at this point possible, among which we have to choose. But luckily, I have the answer for you, and it's STTP. So just a side note, the author of STTP is at this conference. Adam Warski was presenting in the morning. So if you have questions about STTP in particular, you can go to him directly. So we need this. Once again, we need our basic API, adding node and getting nodes. And the best thing about STTP is that it is very, very generic. So it's basically just an API on top of the HTTP protocol, but it does not directly deal with the implementation of that. It delegates to the backends. And you can have a backend for like async HTTP client from Java, or to HTTP4S client, or any other HTTP client implementation. And that's basically it. You have a R type parameter, which is a wrapper around the response, and you have the S, which is used for streams, but it's not that important. And the API itself is very clean, very simple. It's just basic HTTP stuff. So you declare the method, you send the request, deal with the errors, and that's it. But we need to handle our JSONs, right? So we were using CRC before, and we probably still want to use CRC. And STTP comes with CRC support. So you import a single thing, and you can put your case class directly into the body, and the STTP will automatically deal with that. So next thing is that STTP has a backend compatible with what we already used. So we were using Katz effect stuff, but we are also using FS2. And there is this async HTTP client FS2 backend that is exactly what we wanted. And what does it mean? You will see that in a second. So we need streaming, right? So how to deal with that? Because we have a backend based on the FS2, when we consume a stream from the server, STTP will give us a stream of bytes. And then we need to do something with it. And what do you do with bytes? You need to decode strings for it, probably with UTF-8. And then you need to parse the JSONs and decode stuff. And because CRC itself also comes with a support for FS2, it's quite easy. So you just get the bytes, and this flatten you can ignore, but then you put it through the byte stream parser that comes out of CRC FS2 support, and that's it. You get the stream of JSONs out of the box. Then you just decode your stuff from it, and that's end of story. And another nice thing about STTP is that it's so generic that you can use it not only in functional programming when you wrap everything, or in the reactive programming when everything has to be a future. You can, if you're in a scripting environment or in a data science notebook, you can still use it with the ID backend. So ID allows you to not have a wrapper type at all. So when you execute the request, you get the response back. Totally synchronous, totally unsafe, can throw you hundreds of exceptions, but it doesn't matter in some use cases. And STTP allows you to reuse the code, basically. So yeah, we have this 100,000 of different options, and still we're not complete. We covered only the most basic stuff of application development. So what else is there? Probably you have seen that we have some duplication between the client and the server when it comes to the endpoint definition. So on the both sides, you have to specify paths, methods, body formats, and so on. And if you want to get rid of this duplication, you can use either endpoints or a Tapier. So Adam was also talking about Tapier in the morning. And both of those libraries are fine with HTTP4S and STTP. Then maybe you want to parse something out of the body of the, like the content of the node or some other text. And you can use the Atto for that. Atto is a purely functional text parsing library. And the first nice thing about Atto is that parsers are monads, so you can use them in the 4 comprehensions. So each of those ubyte and char, these are just parsers. You compose them with flat maps. And another nice thing that currently is probably unique to Atto is that these parsers are incremental. So it means that you don't have to put all your data up front to get the result. You can give it chunks and receive the stuff as they come. And Atto also comes with FS2 support. So you can take the stream of characters from the keyboard, for example, and parse this as the user types, not waiting for the whole input to come, like without no enter or stuff like that. Or maybe you want to deal with binary data. So you have this scodec library, also works with FS2. Maybe you deal with Kafka, and Kafka has streams, so it's logical to use FS2 for that. So you have FS2 Kafka. If you don't like REST and you're dealing with gRPC, you have FS2 gRPC. So every call is an effect type, and streams are encoded as FS2 streams. If you have a very slow API and you want to cache stuff, you can use ScalaCache. And it's also compatible with Cat's effect, but it's also similar to STTP. It works with futures, tries, IDs, and other stuff. So it's very, very generic. Maybe you want to get more type safety into the equation, so you have this refined library to keeping stuff positive. But then you need to teach these other libraries how to use that. And it turns out that almost everything is already integrated with refined, and you can use it with some single import, probably. And the same applies to enumeratum. So when you want to declare enums before the Scala 3 comes, you probably want to use that. And it also integrates with almost anything. And this is purely impressive. Maybe I can try reloading. Nope. OK. You're not going to see the pictures. Sorry. And there's more. There are still more libraries you could use. So the ecosystem is really, really huge. So I have to move fast now. But how is that possible? The first reason is that these are type classes. So whenever there are 2 libraries, they do different stuff. Like refined deals with the type safety, CRC deals with JSON, but you need to integrate them together. You don't want for neither of them to depend on the another. And then with type classes, you can define the instances in a separate package, separate module. So you're not forced to use any of those, but still you can leverage the support. Then you have cats, which is a very low-level library for composition. You compose stuff like in decline, Cyrus, Atto, and so on with the syntax provided by cats. So the rules of composition are always the same. So you don't have to reinvent them. You just reuse that. And then you have Cat's effects. So whenever you deal with side effects like HTTP calls, database calls, or stuff like that, you have Cat's effects to allows you to have the same code, but for different effect types. So Monix, Zio, Cat's effect IO, that's basically the purpose. And then there's FS2. And more often than not, you need some kind of a streaming library. And so FS2 is there to support you. And because a lot of libraries are built on top of that, the integration between them is seamless, as you have seen between Doobie and HTTP4S. You don't need any kind of conversion. Yeah, and on top of that, or at the bottom of that, there are people. So all the stuff, all the integrations were created by people, their time and effort, so it's good to appreciate that, because otherwise we would have to write those integrations ourselves. And why is that important? So first of all, it's reuse of code. So whenever there is some space between two libraries, and this space is filled by the integration with the support, someone had to write that. Someone had to test that, eliminate bugs, and so on, and we are reusing that code, which is beneficial. But it's not the biggest advantage. The bigger one is the reuse of knowledge. So whenever you use one of those libraries, and you learn something, for example, about cuts or cuts effects, or FS2, and you can leverage that knowledge in another library that uses the same stuff. So you become more productive having a good ecosystem of libraries. But even more important is that all of those libraries, they share the same programming model, the same mindset. And so in case of this ecosystem I've shown you, you can expect that there will be no uncontained side effects, everything will be effect polymorphic, the composition will be lawful based on the cuts type classes that have to obey some laws. And the resources like closable connection pools will not be given to you directly, but instead you will get either a stream or a resource, so something that will automatically close it when you're done. And it's important to remember that there are other ecosystems, like for reactive programming, you have Akka. For more user-friendly, maybe, you have Zio, functional programming. And for scripting and notebooks, you have Lee's Python libraries, like Python in Scala. And that's all I have for you today. So my name was Wojtek. You can find me on Twitter. There's this link for this presentations. If you go there, there's also a feedback button then if you want to leave me a comment anonymously. And that's it. Thank you.
Thank you, Wojtek. Thank you, Wojtek. Спасибо, Wojtek. У нас есть ровно время на 2 вопроса, поэтому на английском, пожалуйста.
Hi, Wojtek. You were talking, like one of your last slides was about how the type classes help to kind of make this system come together. And at the same time, I remember in the morning, John was saying that, well, type classes are snake oil. And in general, ZIO seems to move away from using tagless final and kind of this style of encoding. Mm-hmm. And do you have any thoughts or guesses how it would continue to evolve? Will it just become an ecosystem of its own, or will it keep being compatible with, or rather, how the ecosystem will the ecosystem around current cats effect and kind of friends will it stay compatible with ZIO, or will the libraries move apart from each other? So
here the case is that by using ZIO directly, you get more features out of ZIO, because when you start to do this via type classes, you limit yourself just to some parts of features. So if you want the full power, you go directly with ZIO, but if you can constrain yourself, you can give this freedom to the user to choose. So this is something you do as a library author. And about the compatibility, I believe that even though John was decommunicated, or like excommunicated from the CATS effects, there are still guys who maintain those instances on the ZIO side for the CATS effect type classes. So there is still the support there, and it's still maintained. So you would have to ask John, but I think it's still a viable option for the tagless final style.
Thank you, Wojtek. It was a great talk. So in your talk, it looked like you've chosen randomly some things. Somehow you came up to a very lucky thing, because you've chose FS2, and all of a sudden everything is compatible to, it composes with FS2, because FS2 is clearly a conduit of Scala nowadays. So don't you think that out of 1,000 of hundreds possible stacks. Not all stacks that convenient because you have to convert because between stream implementations and so on.
Yeah, that's exactly the case. And that was also the main purpose of this talk, so show you that there are a lot of options, but most of them doesn't make sense. But there is this single option, or maybe some variants of it, that are called ecosystems, or can be called so. And then when you choose the libraries from the single ecosystem, they work really well together. So the libraries itself comes with the problem of choosing the stack, but the ecosystem chooses the stack for you and gives you this nice framework-like experience. But all the other options, like if you start mixing Lee, Hayoi's libraries with functional programming, it's not gonna end well. So.
Похлопаем еще раз. Спасибо.